We're taking another trip afield, and we're going to explore global learning in the STEM disciplines: science, technology, engineering, and mathematics. Dr. Ibrahim Tansel received his doctoral degree from the University of Wisconsin-Madison, and he joined FIU in 1990. He established the Mechatronics Laboratory, that is a new word for me, and has been directing it for over 20 years. Dr. Tansel works on automation of manufacturing, health monitoring, and development of computational tools for various engineering applications. He's taught many courses, including manufacturing, mechatronics, and system identification. So, Professor Tansel.
In this presentation, I'm going to talk a little bit about what we are doing to include the global learning into our curriculum. If we look at the technical side, from 1900 to 2010, there is not that much difference. We are using computers more, and we, instead of slide rules, we are now using the computers, and sometimes our students are preferred compared to people who has 20, 30-year experience in the field, because they can run some of the software better than the other experienced engineers. However, on the other hand, when it comes to the global operations, the world changed a lot. And we are not following that trend that closely. At some point, we don't have time. We can only cover the technical issues. But if we are going to look at the 1900 to 1940, the manufacturing was local, and the universities were preparing basically the people with the technical knowledge. So for that little world, whatever is going on, we are still following the similar type of education. However, if you look at the world after 1960s, the world changed a lot. International trade increased, and at some point even it becomes worrisome. So some trade limits were established, especially for the auto industry. And today it is much more different. There are major independent suppliers. You tell them that I want this iPhone, this is the design. They send you 1 million of them to the address you give at the time you tell them. So the engineering is very different now. We are not just dealing with the manufacturing operations. The engineers are managing factories in the foreign countries. Sometimes they are giving orders to the suppliers. They are not looking into the technical sides of it. Sometimes they are working for the foreign companies. They are not the real decision makers. And sometimes they are selling the foreign products. So in this world, the expectations from the engineers are very different. So we couldn't include them into our curriculum. Now, if you look at the expectations from engineers, now one of the main issue is cost cutting. Everybody wants the engineers to make the things cheaper, and it is a big problem. And then the ethical expectations are increasing, legal expectations are increasing, regulatory requirements are increasing. It is very difficult to include these things into the curriculum. It is very difficult to prepare the student. Basically, almost we completely ignore this issue. At the same time, the development times decreased. Like if you look at the car industry, every 3 years a new car is coming out, and they have to change the model, they have to cut the cost, they have to make some improvements. There is almost no time to think about what to do. If you are going to look at the electronics industry, then the development is much more faster. They have to come up with the new thing almost in every 6 months. Like if you look at the Cellular phone market, Samsung is coming up with a new product in every 6 months in these days. So it is very difficult to follow the trend. At the same time, the global competition is increasing. There are many companies in the world, and like if you consider China, if you consider the India, there are lots of very large customer bases there. So very strong companies are suddenly showing up on the map. It is very difficult to compete with them. At the same time, people are trying to automate the factories. So the automation is at some point nice, but at the same time, it is isolating the people from the machines. So you don't know what's going on, how hot the machines are getting, what is going on. The things comes out as a surprise. And at the same time, the coupled movement is towards to the software and healthcare. Although we know that we have to develop the product fast, we know that we have to include more computers, more electronics, and other things. But if you look at the venture capitalists, they don't want to give the money to the manufacturing or the conventional things. They want to give the money to the software and that software companies, or they want to give to the healthcare because the profitability is higher. So under these pressures, if you look at the two major accidents, really the engineers are blamed eventually, but I don't know how they could avoid it. At some point, Toyota today is most powerful manufacturing company. Like if you look at the MIT's curriculum, they are teaching Toyota's books about the quality control. On the other hand, these guys got into trouble and they paid $1.1 million fine, although their mistake has never been proven. But that was had to be done. If you consider the British petrol, they were using the pretty high-tech industry, and you saw under the water they could get images, they can send robots, they can do all those things, but they needed to pay $4.5 billion fine. And all these things, if you look at there, the problem goes to the engineers. And so we try to include a movie in our course to give some idea about this type of work. So basically we know that we have to include the global knowledge, awareness, perspective, and engagement in our curriculum. But our problem is the state limits the number of courses the students can take, the number of credits they can take. So we included these things into our ethics and design project organization and senior design project courses. So what we do is we are showing a movie that is Incident at Morales. Once you buy this movie, they allow you to play at any department in the university. So if anyone interested in, we can give a copy of it. At the same time, we ask students to write an essay based on the code of ethics of the ASME after they watch the movie, and to say like what was done wrong in that movie. It is very easy if you are an academician, if you are not a really practicing engineer or the lawyer of a company, you can say everything is, yeah, they did it everything wrong. They had to spend 2 times more money. They had to spend 10 times more money, but in practice, everything is different. So hopefully in future, we are going to be getting to those aspects too. Also, in the senior design course, we asked the students to look at the literature which is coming from the foreign publications. At the same time, we asked them to identify the most powerful companies in that area in the world, and then to see what they are doing and to include their design, something from their applications. We asked the students to use the international units in their report. So anyone from another country can easily follow what they do. And at the same time, we ask them to use those components carefully, like when they use the power supply, which is with the 110 to 120 options, so which can be used in many other countries. So this is the movie which we show them. The idea is there is a US engineering base for a French company. The headquarters in France. They decide to build a new product line in United States. And then they decide the product. They define the process. However, French company wants them to cut the costs. And then they design the factory at the borderline. So they say that, okay, for this process, we have to use these temperatures, we have to use these pressures, and then they take the safety margin and they select their equipment. At some time, the engineer discusses with his wife about the water treatment issues. His wife works for EPA, so she suggests using better water treatment facilities, and the engineer asks at the company. He succeeds it, but of course his boss gets pretty upset about this thing, because at some point the cost is increased, and so on the water treatment side, they do a little bit something good, but at the same time, by discussing with his wife, he is violating some of the code of ethics. So, and then suddenly they see that their product is not going to be competitive in the market. There are certain issues with the product. So make that product with the qualities which is going to make them competitive. The process temperature has to be increased a little bit. The pressures has to be increased a little bit. And then they observe some of the problems at the factory, although the process is working, but there are some little leaks. So they say, okay, after the first year, doing the maintenance, they can change them, they can fix those problems, but unfortunately, some accident happens, some person dies, and an investigation starts. So this is one example, and again, if you consider the BP's and Toyota's experiences, still you can see so basically, if we consider the engineering, it is a very demanding profession. Every day we have the pressure of reducing the cost, to reduce the production time, and we have to satisfy the continuously increasing legal, regulatory, and ethical expectations. So it is very difficult to prepare our students for all these issues. And at that point, we like this pressure which is coming from global learning. So we have a little bit excuse to include them into our courses, but still we have very short time. So it is not easy, but we are doing piece by piece, and we are trying to include them into hope that it will help them in their professional lives.
Absolutely. Thank you. And to tie together the things that we've been hearing about so far. So you experience in your professional teaching life the same kind of pressures that professional engineers do in order to get this curriculum, this component into your curriculum. And so, our work in our office is to help to relieve those pressures whenever possible. So we have the good folks in the libraries to assist you to locate the case studies, the films, to purchase those. We have folks in student affairs who can help with, if you're teaching in a large class, to facilitate peer discussion leaders to get that kind of thing going. And I'm going to say the dirty word now, assessment. Your case study and the work that your students do really gets at global awareness, that knowledge of interconnectedness, and global perspective, the ability to look at an issue like this like this, the problem in this case study from multiple perspectives. And our office can provide to you language for rubric criteria as you are assessing students' performance artifacts, whether they be discussions, presentations, research papers, and things like that. And you can contact us. So soup to nuts, we try to help support your work. Thank you so much.
Thank you.